Good morning students, this is Premchand, Chemistry Faculty, Vikas Global Institutions, Jangaredgudem. Yesterday we were discussing about how scientists were able to find out the subatomic particles through their experiments. Mainly we have seen about electron and proton, right? We'll revise a bit once more. Who found the electron? It is found by J.J. Thomson. Who found the proton? It is found by Goldstein. And we also saw the charge of a electron. At the same time we also saw the charge of a proton. Charge of an electron is minus 1.6 into 10 to the power minus 19 coulombs. Coming to the proton, it is plus 1.6 into 10 to the power minus 19 coulombs. At the same time we also saw the mass of an electron and mass of a proton as well. So today we will see about one more fundamental subatomic particle, that is neutron. Alright, so this neutron is found by Chadwick. It is found by Chadwick. And why did he find so? Because there are negatively charged particles called electrons. At the same time, there are positively charged particles called protons. But there was a need to find there are some neutral particles are also present in the atom. So they started investigating the things, and finally Chadwick was able to find there are some particles which are neutral in charge as the subatomic particles, that is neutron. So charge of a neutron is charge is 0, it doesn't have any charge. And while coming to the mass of a neutron, mass is which is almost equal to that of the proton. So what is that? So mass of a proton is 1.673 into 10 to the power minus 27 kg. So this one is 1.675 into 10 to the power minus 27 kg. So this is the neutron. How did he do the experiment? Means what he did was he took the beryllium or boron atom. What is the atomic number of beryllium? 4. He bombarded this with alpha particle, and then he got something called carbon atom and neutron, which is having charge of nothing. It doesn't have any charge. So we'll summarize whatever the subatomic particles we have seen till now. So we'll summarize that. So the first one is subatomic particle. First one is electron, next one is proton, next one is neutron, right? These three things we have seen. So who found or discovered by whom? This is by J.J. Thomson, this is by Goldstein, and neutron by Chadwick, right? So we also saw the charge of an electron. Charge. What is the charge of an electron? Minus 1.6 into 10 to the power minus 19 coulombs. And what is the charge of a proton? It is plus 1.6 into 10 to the power minus 19 coulombs. Charge of a neutron is 0. If you take it to a relative charge, which means with respect to one another, relative charge, relative is the word which is used always to see with respect to the other. So if you see the relative charge, What is the relative charge? This is having -1, this is having +1, this is having 0. Neutron is having 0. We also saw the mass of an electron. What is the mass of an electron? Right. So 9.1 into 10 to the power -31 kg, and that of a proton is 1.673 into 10 to the power -27 kg, and that of a neutron is 1.675 into 10 to the power -27 kg. Right. If you see the relative mass, if you see the relative mass, these both are almost equal. So 1 1. Regarding this one is, this is 1 by 1837. 1 by 1837th of the proton or the neutron, which is almost negligible mass. It is having what? Electron, right? So if we also saw the charge to mass ratio, what is the charge to mass ratio of an electron? This is 1.75882 into 10 to the power 11 coulombs kg inverse, while that of the proton is 9.58 into 10 to the power 7 coulombs kg inverse. Since neutron is not having any charge, so this charge to mass ratio of a neutron is 0. This is a gist of whatever we have seen, or the whatever scientists have found the charge and mass and charge to mass ratio of the subatomic particles. This is the final thing that we should be aware of, right? Right. Then we'll also take a look at atomic models today. In previous classes we have seen few atomic models, right? We have seen, right? So just like Dalton's atomic model and all. So before going to see the atomic models, there are few challenges. To propose the atomic model, there are few challenges for a scientist. What are they? Challenges to propose an atomic model based on these subatomic particles. Okay, there are subatomic particles. How do you present your theory, or how do you propose your theory? There are few challenges. They are, how do you account for the stability of an atom? First one, stability. You have to account for the stability of an atom by including all these subatomic particles. If subatomic particles, whatever you are saying is there, how is the stability of an atom? At the same time, there are different elements. So how do you explain the properties, physical and chemical properties of elements? Chemical and physical properties. How do you explain the physical and chemical properties of different elements? Because two different elements are different in both, like physical and chemical properties. How do you explain them? That is one of the major challenges for them in that at that time. At the same time, they also had few challenges, like to explain the formation of different compounds as well, like how different compounds are formed, or how these atoms are combining in what ratios and all, and also to explain the electromagnetic radiation. How does these atoms, or few atoms are emitting the electromagnetic radiation? They ought to explain them, right? So what are they? Formation of compounds, and electromagnetic radiation. They have to explain, they ought to explain all these properties. The first attempt was given by Dalton. He is one of the great scientists. We have seen his theory in our previous classes as well, right? So Dalton's theory, Dalton's atomic model. Dalton's atomic model. He was the first one to propose or to explain completely about an atom. He was the first given attempt. It was the first given attempt, right? So based on what he made his theory is law of conservation of mass. We all know, right? What is law of conservation of mass? Right. So matter can be neither be created nor destroyed. It transfers from one form to the other. Right. So based on that and law of constant composition, so all this matter is formed with certain composition, right, or certain amount of proportion. They are mixed in a certain proportion. That is what based on these two principles his theory is based. So we'll see what are the points that he stated, right? So the first one is all matter consists of atoms. Matter is made up of atoms. Made up of atoms. The first one. And the second one is all atoms of a given element. If you take something, some element like hydrogen, all hydrogens will have the similar kind, like the same properties. Same properties it will be having. All properties of a given element are same. They are not very much different. And he also told that compounds, right? He also told about the compounds are a combination of the atoms. That is what his proposal is. So that is one of his assumptions, right? So compounds are formed by the composition of different elements, right? And also he told something about the reaction, chemical reaction. He told chemical reaction is nothing but atoms, like they are the rearrangement of an atoms. That is what he exactly told about the chemical reaction. What he told about the chemical reaction? Chemical reaction is a rearrangement of atoms. అంటే ఏంటి? కెమికల్ రియాక్షన్, ఒక రియాక్షన్ జరుగుతుంది అని అంటే సేమ్ యాటమ్స్ ఉంటాయి, కానీ అవి ఏమంటే రీఅరేంజ్మెంట్ జరుగుతాయి, ఇక్కడిది అక్కడికి అక్కడిది ఇక్కడికి జస్ట్ రీఅరేంజ్ అవుతాయి అని మాత్రమే. దీస్ ఆర్ ది postulates or the assumptions of Dalton's atomic theory. But it failed in many ways, like we know that. So he could not explain electrical and magnetic properties of elements, right? Many things this theory could not explain. So the other theory came up is J.J. Thomson atomic model. J.J. Thomson atomic model. So we'll see what J.J. Thomson assumed or he put forward his theory. So J.J. Thomson atomic theory. What did he say? We all know, like little bit of things regarding the J.J. Thomson model we already listened in our previous classes. So what are they? We'll see now. All right. So this who J.J. Thomson atomic model. We'll say this is J.J. Thomson atomic model. Mainly what he told is, his model is also called what? Right. So his model is also called watermelon model. Watermelon model. So it is just like the atom is just like that of your watermelon. How? Just like ఎప్పుడైతే మనం పుచ్చకాయని చూసి ఉంటాం కదా, వాటర్మెలన్లో ఎలా అయితే సీడ్స్, బ్లాక్ సీడ్స్ ఇన్సర్ట్ అయి ఉంటాయి కదా అక్కడ సేమ్ అదేవిధంగా ఈ యాటంలో కూడా ఎలక్ట్రాన్స్ అలానే ఎంబీడ్ అయి ఉంటాయి, అంటే అక్కడక్కడ ఉంటాయి అని చెప్పడం జరిగింది. ఎట్ ది సేమ్ టైమ్ ద పాజిటివ్ ఛార్జ్ దట్ ఈస్ ప్రజెంట్ విత్ ఇన్ ది యాటమ్, పాజిటివ్ ఛార్జ్ కూడా ఉంది కదా యాటంలో. సో ఆ పాజిటివ్ ఛార్జ్ అంతా కూడా రిమైనింగ్ ఆల్ మొత్తం యాటంలో అంతా ఉంది. సో ఎలక్ట్రాన్స్ అక్కడక్కడ ఎంబీడ్ అయి ఉన్నాయి. దట్ ఈస్ వాట్ హిస్ థియరీ ఈస్ ఆల్ అబౌట్, వాట్ హిస్ థియరీ సేస్. దట్ ఈస్ వాట్ హిస్ థియరీ ఈస్. Right. So it is the J.J. Thomson model. What are the main points regarding the J.J. Thomson model? We'll see now. Atom. He is saying about the atom, right? Atom is with atomic radius of 10 to the power minus 10 meters. 10 to the power minus 10 meters also can be called as 1 angstrom. 1 angstrom. How do you write this? This one. How do you 1 angstrom. So atom is with atomic radius and it is in a spherical shape. Spherical ante idea unda. So this is basically a circular. Endukante board మీద రాస్తున్నాను కాబట్టి it is a circular. Spherical in the sense, in 3D it's like a ball, right? Cricket ball, volleyball ball. So it's a spherical shape and it is in spherical shape. All right. So this was the first point. So atomic radius is of 10 to the power minus 10 meters radius. That means 1 angstrom radius, and it is in a spherical shape. And the other thing is main point, right? So the main point is electrons are embedded in the atom just like that of watermelon seeds. ఎలా అయితే వాటర్మెలన్లో సీడ్స్, బ్లాక్ సీడ్స్ ఎలా అయితే ఉంటాయో సేమ్ అలానే ఎలక్ట్రాన్స్ అన్నీ కూడా యాటంలో అక్కడక్కడ ఉండబడి అని చెప్పాడు. ద నెక్స్ట్ అదర్ పాయింట్ ఈస్ ద పాజిటివ్ ఛార్జ్ ఆఫ్ ది ఆల్ సబ్అటామిక్ పార్టికల్స్, వాట్ ఎవర్ పాజిటివ్ ఛార్జ్ ఇస్ ప్రెసెంట్ ఇన్సైడ్ ది యాటమ్, ఇట్ ఈస్ యూనిఫామ్లీ డిస్ట్రిబ్యూటెడ్ ఓవర్ ది యాటమ్. యాటమ్ అంతట్లో కూడా మిగిలిన రిమైనింగ్ పార్ట్ అంతా కూడా పాజిటివ్ ఛార్జే ఉంది అని చెప్పాడు. ఏమని? ద పాజిటివ్ ఛార్జ్ ఇన్సైడ్ ది atom is uniformly distributed, which also means the mass of an atom, right? The mass of the atom is uniformly distributed, because electrons are having very negligible mass with respect to the positive particles. So the mass is also uniformly distributed. Mass is uniformly distributed. That is what the J.J. Thomson told. But in the later experiment, he could not explain many of the properties, like how the mass is present like uniformly distributed over the atom. He could not explain, like because he made this statement, he cannot explain many things. At the same time, electrons are just sitting like that inside the atom, just like that of watermelon. He could not explain many things. And also these are the things he could not explain. So there is one more atomic model, that is Rutherford atomic model, right? Rutherford came up with a much more modified atomic model. We'll see that atomic model now. What was that? Rutherford atomic model. Rutherford atomic model, or this is also called what? Planetary model. Rutherford atomic model. So to tell his atomic model, he did an experiment. What did he do? Rutherford gold foil experiment, we all know. So once again we'll see that. So this is the source of alpha particles. Source of alpha particle. So when they are coming, we'll keep a lead plate. And we also keep a phosphorescent plate. Right? So when these particles are coming and hitting a thin gold foil, then they observed some deflections. These particles are coming and hitting at different points in this phosphorescent plate. So this is lead plate. So this is gold foil, which is of 100 nanometers, 100 nanometers thickness, that means very thin gold foil. This is a phosphorescent plate. What they used is ZnS, zinc sulfide, so that whenever these particles are coming and hitting, when there are some deflections happening, so it is coming and hitting in a different directions of the phosphorescent plate. So based on his observations, he gave few points, like what are his observations, we'll see now. Right, so we'll see all these points now. So if these are the atoms present inside the gold foil. So what is happening here is, there are few rays which are going straight without getting any deflection. There are few rays there are few rays which are getting deflected a bit. There are few rays that deflected more. There are few rays which bounce back. All right. So these are the observations he made by the Rutherford. So what are the observations? We'll see. Most of the alpha particles pass through the gold foil undeflected. Most of the particles, many of these all particles went undeflected. Most alpha particles went undeflected. Deflected in the sense they are changing their angle and they are not going in a straight line, right? So most alpha particles went undeflected, which means they went in a straight line. From this point, what he came to a conclusion is that when you are taking an atom, most of the part is free. Most of the part in an atom is free. Most of the atom is very much free. That is why when some alpha particles are coming, they are going undeflected. Most of the alpha particles went undeflected, which means he came to a conclusion that most of the volume of atom is free. Right, most of the space is very much free, and a few positively alpha particles, like why alpha particles? What is an alpha particle basically? So alpha particle is helium atom when we are removing 2 electrons from it. If you are removing 2 electrons, it gets a positive charge here. So this is the alpha particle. So this alpha particle is having a positive charge. So when alpha particles are coming and going through the atom, some particles are getting deflected. Why these positively charged particles are getting deflected? Because there is something positive charge inside the atom. There is some positive charge inside the atom. Some particles get deflected. Why? Because there is some positive charge from this, what he made, some positive charge is there inside the atom. And he also told very few rays, very few alpha particles bounced back, like it went in the same direction and it came back in the same direction. Bounced back, that is 1 in 20,000 particles came back, it bounced back. That means he came to a conclusion based on these things. The positively charged, whatever the positive charge inside the atom, that is densely concentrated in a very small region. Positive charge in the atom is densely concentrated in very small region. In a very small region, the whole positive part is, it is densely concentrated, which means densely packed inside a very small region of the atom. So, and another thing is calculations, like he also did some calculations, this Rutherford along with his students, he also made few calculations and calculated that what is the atomic radius of this one atom? It is 10 to the power 10 meters. But compared when it comes to the positive charge inside this inside the atom, right? So if this is an atom, the positive charge is here, only here, very little. So the atomic radius of the whatever the positive charge which is concentrated is 10 to the power minus 15 meters, very much less. Okay, so then he called this whatever the densely packed inside, that he called as nucleus of the atom. He called that as a nucleus of that atom, where this positively charged is densely packed. And by his time, electrons are already found out. So how he would explain the presence of electrons? What he did was, so electrons are not just sitting inside the atom, they are revolving around the nucleus. He called it as a nucleus, right? So electrons are revolving around the nucleus, just like planets are revolving around the sun. That is why this model is called planetary model. And these electrons are revolving around in a certain path. He called that path as orbit. Orbit is, according to his definition, is what? Wherever the electron path, where electron is revolving around the sun, sun చుట్టూతే ఎలా ఎక్కడైతే ఏ పాత్లో అయితే రివాల్వ్ అవుతూ ఉందో ఆ పాత్ని ఏమన్నాడంటే ఆర్బిట్ అని పిలిచాడు. ఎవరు? రదర్ఫోర్డ్. ఓకే, సో then how, if these electrons are revolving, they should come out, right? But what he told is, by electrostatic forces these electrons are held together, which means electrons అక్కడ ఎలా ఉండగలుగుతున్నాయి? మనకి సెంట్రిఫ్యూగల్ ఫోర్స్ తెలుసు కదా, సెంట్రిఫ్యూగల్ ఫోర్స్, సెంట్రిపెటల్ ఫోర్స్ is dragging you inside, centripetal force will force you outside. When electrons are revolving, when they are revolving, there is centripetal force which makes it to go outside. Why it is not happening? Because of the electrostatic attraction. So the last one is electrostatic attraction. Because of the electrostatic attraction, they are not going outside. This is what the Rutherford theory is. So we'll sharply take a look at drawbacks or the failures of Rutherford experiment or the Rutherford atomic model, and then we'll continue for tomorrow. Defects or failures of this model. Defects or failures of this model. What are the defects or the failures of Rutherford model? So we'll see that. First thing what he could not explain is, he could not explain the stability of an atom. Couldn't explain stability of atom. Stability of an atom, right? So like discussed earlier, so electrons are revolving, positive charge is there inside, but how atom is stable? He could not explain. And by one more theory, like electromagnetic theory, some Maxwell's laws are there, right? So according to that, if a charged particle is revolving around a nucleus, if a charged particle is accelerated, which means if charged particle is having an acceleration, then there is a current is produced. At the same time, it also emits some radiation. If charged particle is accelerated, particle is accelerated, it continuously emits radiation. He could not explain that. And that whatever the since charged particle electron is revolving, it should emit radiation, and at some point of time it should finally collapse into the nucleus, but that is not happening. But atom is stable. Why it is that? He could not explain. And the spectrum, atomic spectrum, also he could not explain why it is not coming. Atomic spectrum. If it is emitting continuously radiation, the atomic spectrum should be continuous. Something like this. It should be continuous function. Should be a continuous function. But what we see in the atomic spectrum is, we see the lines like this. We cannot see something like this, some continuous function, but it's a line spectrum we will see in the atomic spectrum. Why it is that? He could not explain. Who? Rutherford. Alright, so these are the drawbacks of Rutherford. And also he could not explain what he was telling about the electrons. He was telling about the electrons, they are just revolving around the nucleus in a circular paths called orbits, but he could not explain the electronic structure. Of the atom. How they are actually present, the electrons, he could not explain. So these are the defects or failures of Rutherford model, what you have seen today. We summarized about the subatomic particles, and also we have seen how neutron is by what experiment they found out the neutron, and also we saw the Dalton's theory of atomic model, and we have seen J.J. Thomson atomic model. We also saw Rutherford atomic model. Before that we also saw the gold foil experiment of Rutherford, and also we saw the Rutherford atomic model or planetary model, and we also saw the failures. So tomorrow onwards we will start the objective session of all these classes. So please read all the topics whatever is covered, so that objective part will be doing. Thank you.